In 3.3, we are looking at some properties of functions. So first we're going to look at some properties that we can identify by looking at a graph. So for the function graph, first, let's find the intercepts, if any. So we can find the x-intercepts by looking at the points on the x-axis of the graph. And we see two x-intercepts. So the x-intercepts are -1, 0, and 1, 0. Y-intercepts will be the points on the graph that are on the y-axis. Here, 0, 1. So we have one y-intercept at 0, 1. Okay, let's look at the domain and range. The domain, we're looking at the x-axis and looking at the leftmost and rightmost x values. Now, it's important to note that the endpoints on this W-shaped graph are solid closed circles, so they are included. So our domain goes from -3 to +3 with squared off brackets on each end. So -3 and +3 are both included in our domain, and every real number in between them. Our range, we're looking at the y values. Our lowest y values are 0, and our highest y values are 2. So our range goes from 0 to 2 inclusive. C, we want to know the intervals on which the function is increasing, decreasing, or constant. So this function is increasing on this interval right here. And what we want to identify are the x values for all the points of the function in that area where it's increasing. So it's increasing from x equals -1 to x equals 0. And for these intervals, we will not include the endpoints. So these are considered open intervals. So it's increasing from -1 to 0, and then we have a second interval here from 1 to 3. It's decreasing first from -3 to -1. Again, remember we're looking at the x values. And then it's also decreasing from 0 to 1. Intervals where it's constant, well, on this graph we have none. We would be looking for areas where we have a flat or horizontal line part of the graph where it doesn't change. Okay, D, we are determining whether the function is even, odd, or neither. Now, we're looking at the graph to determine this. And a function will be even if it has y-axis symmetry. So can we fold this on the y-axis and have the graph fold onto itself? Yes. To determine whether it's odd, if I were to rotate this graph 180 degrees about the origin, would it look identical? So originally this is a W-shaped graph. If I rotate it 180 degrees, it'll be an M-shaped graph. So no, so this is not odd. If it was neither, if we answered no for even and odd both, then we would say neither. So this is even but not odd. We want to identify the local minima. So we are looking for low points on the graph. And we see two of them. And not only are these local minima, but they're also absolute minima. These are -1, 0 and 1, 0. And for F, we are looking for local maxima. So we have 1 right here at 0, 1. Now, it's important to note that for local minima and maxima, we would not include the endpoints. So we would not include negative 3, 2, and positive 3, 2. Okay, let's determine algebraically whether each of these functions is even, odd, or neither. So on the previous slide, we looked at it from the graph. Here we will do it algebraically. So for both of these, we want to start out by determining what f of negative x is. So f of negative x for this first function is negative 3 times negative x squared minus 5. Simplifying, that is negative 3x squared minus 5. And that happens to be identical to our original function. So because f of negative x equals f of x, this function is even. Again, for f of x equals the cube root of x, we will start off by determining what f of negative x is. F of negative x equals the cube root of negative x, which is equivalent to the cube root of negative 1 times the cube root of x, or negative cube root of x. Now this is the opposite of what we originally had. So f of negative x equals the opposite of f of x. So this second function is odd. If f of negative x was not f of x, and it was also not the opposite of f of x, then it would be neither.